Alright, this time we have a responsibility of simplifying these two questions. They look like they are a bit tough, but don't worry. When we solve them, you will see the little tricks we are going to apply to make the work easy for us. Welcome to Whiteboard Math Party. If you've not subscribed to this channel yet, please do so today. You will enjoy it. You will never regret it, trust me. Okay, let's begin. First of all, let's solve the first problem that says we should simplify this mighty fraction right up here. So begin this way. Looking properly at this question, you see that almost everything is in the power of 2. So what I'm going to do is, for that numerator where I have 4, I'm going to change it in the power of 2. So instead of writing just 4, I'm going to express it this way. 2 to the power of 2. Yeah, that relieves me a bit. And you know what? This 2 to the power of 2 is exactly multiplying whatever is inside this bracket. So I'm going to write it as 2 to the power of 2 multiplying 2 to the power of n plus 1, right? Yeah, that's n plus 1. Minus 2 to the power of n plus 2. Minus 2 to the power of n plus 2. Okay, that's my numerator as usual. Why my denominator? I can express my denominator the same way it is anyway. So I'll just leave it as 2 raised to the power of n plus 1 minus 2 to the power of n. Okay, let's take it a bit further. This time around, what I'm going to do is, since I have 2 and 2 the same base, I'm going to work them together, right? So what I'm going to do is simple. I just have to take, I'm working out this part and this part together now. So I take one of the bases, which is 2, and I add the powers. So if I add the powers, it's going to become n plus 3, or 3 plus n, you know? I did this because 2 add 1 is 3, and this is the n, so that's n plus 3. Minus 2 in the power of n plus 2, still on my numerator. All divide by, yes, look at the denominator. There is something I can actually do here. Since I have 2 to the power of n plus 1 and 2 to the power of n, I can factor out 2 to the power of n and simplify what's left. So if I factor out here 2 to the power of n, open bracket, how much do you see here? See, this is 2 to the power of n times 2 to the power of 1. That's what gave us this value. So it means if I leave 2 to the power of 1 inside the bracket, 2 to the power of n times 2 is going to give me 2 to the power of n plus 1 because the power here is 1, which is exactly here, factored, right? Minus 1. It's minus 1 because I just need to replicate 2 to the power of n here by multiplying 2 to the power of n by 1, right? Okay, since you've understood this level, now watch the numerator. I can simply factor out something on the numerator also. So I have 2 to the power of n plus 3 here. I have 2 to the power of n plus 2 here. I can work with 2 to the power of n plus 2. So if I do that, I'm going to go with 2 to the power of n plus 2 as my numerator. Open bracket. What do I have to multiply here? I simply need to multiply 2 to the power of 1 because 2 plus the power 1 will give me 3, which is exactly what I have here. So I'm leaving it this way since the power of 1 is not expressed. Minus 2 to the power of 2 times 1 will leave me with 2 to the power of 2, which I already had. So I just write 1 here. All divide by, now let's simplify the one we've done before. It's going to be 2 to the power of n alone because 2 minus 1 is 1. And 1 times 2 to the power of n leaves you with 2 to the power of n. Nothing else at the denominator. So let's proceed. It's getting easier, right? For the numerator, 2 to the power of n plus 2 is still there. 2 to the power of n plus 2 is still waiting for us. 2 minus 1 is 1. So 1 times 2 to the power of n plus 1, sorry, n plus 2 remains the same. So we're leaving our numerator as 2 to the power of n plus 2, while our denominator is 2 to the power of n. Now watch it. Here we have exactly the same basis, which is 2 and 2. So we can apply our division rule. In that case, it's going to be 2 to the power of n plus 2, which is at the numerator, minus, remember when we are dividing, the powers are subtracted, so minus n. If we do that, this n is going to minus n. That will be 0. So we're left with 2 to the power of 2, which I'm going to write here. You can leave your answer as 2 to the power of 2, or you can further simplify it as 4, because 2 to the power of 2 is 2 times 2, which is 4. This is the answer to this big question here. I hope you enjoyed this one. Now let's try number 2. Number two question says if x to the power of 3 upon 4 multiplied by the square root of y over s multiplied by y to the power of 5 upon 8 can be expressed as x to the power of m y to the power of n, find n to the power of m. Well, this looks a bit bogus, but I'm going to make it easy, so don't worry about that, okay? Let's focus our attention right here. What I'm going to do is just a way of simplifying. So see what I'm going to do here, okay? I will start first of all by replicating what's up there. X to the power of 3 upon 4, yes. Now, it's the same as I'm multiplying here. I'm going to simplify this. A big square root covering y and x together can further be simplified as y over x, both of them raised to the power of half. This makes your work easy, right? Now, since I already did this, I just go for that to write this down. Times y to the power of 5 upon 8. You would notice that all I'm trying to do is to simplify my problem. And when I simplify it, that is going to make my work quite easy. Please, this denominator here is x. Don't get confused, okay? X, okay. Now, having done that, it's getting easy. I want to simplify whatever is in this bracket before I proceed. So, I replicate again. X to the power of 3 upon 4 times my numerator here now is going to be y to the power of half. Divide by the denominator becomes x to the power of half. I have shared the powers for them, right? Now times y to the power of 5 upon 8. It's getting easy. Now my work is going to be this. Since this is a numerator on its own, I can express it as x upon 1, y I express this as y upon 1. I want them to mingle. Let the x go close to its brother and let the y go close to y so that my work will be easier. In that case, it's going to be something like this. I'm going to make it x now to the power of 3 upon 4 divides x to the power of half times y to the power of half multiplies its brother y to the power of 5 upon 8. Yes, the work is getting easier now. Now, this is division. I'm going to apply the division rule to this part. And if I do that, it's simply going to become x to the power of 3 upon 4 divide by x raised to power 1 upon 2. So using the division rule, I'm going to make it minus now. We subtract the powers since the bases are the same. And multiply it by y. Here, I'm going to apply the multiplication rule. Since the bases are the same y, I just have to add the powers half and 5 upon 8. My work is getting much easier. In that case, we'll end up having this answer, which I'm going to write down here. In that case, we'll end up having this x still at the base, 3 upon 4 minus 1 upon 2. Use your fraction rule. This is the same as 2 upon 4. So 3 minus 2 is going to give me 1 upon 4 here. 1 upon 4 times y raised to the power of, if I simplify this or make it equivalent to a denominator 8. This is same as 4 upon 8. So 4 plus 5 is 9. I have this as 9 upon 8. Okay, this has been simplified already to the barest. Since we are here already, remember that the question says everything is equivalent to x to the power of m and y to the power of n. Now, this is x, this is x. Our m is represented by 1 upon 4, while our n takes the position of 9 upon 8. So to find the value of n raised to power m, I'm going to use a different color to do this so we don't get too much confused. All right. So what I'm going to do now for n to the power of m, since we already know what each value stands for, it's going to be the same thing as, since my n is the same thing as 9 upon 8, all right, 9 upon 8, close the bracket, to the power of m. What's m? M is 1 upon 4. Okay. So if I make this to become 3 to the power of 2 for 9, close the bracket, raise it to the power of 1 upon 4, because 1 upon 4 is the fourth power, which you see here. Divide by, can we simplify 8? Let's see if we can do that. 2 to the power of 3 is 8, which we can also express in the power of 1 upon 4. So if we further break this down, 2 is going to cancel 2 here, so you have half, which is 3 to the power of half, 3 raised to the power 1 over 2, all over 2 to the power of 3 over 4, 2 to the power of 3 over 4. You can leave your answer like this, or if the question requires you to do more, you can express this as square root of 3 all over the fourth root of 2 to the power of 3. Whichever way you write your answer, either this or this, both of them are correct. Please give us a thumb up if you enjoyed this video, and thanks for watching.